Hi everyone and welcome back to my bench. Today I'm going to show you how you can connect a keypad to an ESP32 to control the LED. The LED is just an indication of what you can have connected to the device, but you can connect anything through a relay to control a door or any other access system or any main connected light. And before we continue with today's projects, I want to thank today's sponsor, which is Altium Develop. If you build electronics, you know how complicated collaboration can get. Different tools, endless meetings, and version chaos that slows everyone down. Altium Develop changes that. It's a cloud platform built for real co-creation, bringing electrical, mechanical, software, and sourcing teams together in one shared space. Instead of jumping between disconnected tools, everyone works on the same data in real time. Designers can create schematics and PCBs, procurement teams can manage parts and pricing, and manufacturing can review designs before production, all in one place. Every change, comment, and decision stays in context, so no one's left guessing. You can track progress, manage requirements, and resolve issues before they become problems. No silos, no delays, just clear, connected teamwork that keeps projects moving fast, where it's easy to bring the right people into the process whenever you need them. If you're ready to move from working together to working as one, check out Altium Develop at the link in the video description. And to make our projects, we're going to be using components from this IoT Starter Kit that a mentor sent for me to try out. It is a nice kit with a nice idea, but some of the items in the kit are not really well thought of, and it kind of disappoints me in that way. And we can start by looking at the cutout for the print cover. You can see that they've misplaced those and they had to cut this with scissors, which I think is a lack of planning, and that lack of planning continues throughout the kit. So let's open it up and see what's inside. Once we open it up, we can see that we have nice layout of all of the components that we get included with the kit, and everything fits really nicely in this box. We can take out this upper tray to include a lot of the components, including the keypad that we're gonna use for our projects. But when I say that the idea is not well executed, for example, there are many components included, but not all of them are relatable and usable in the kit. For example, this kit comes with an ESP32 room module that has a USB mini connector, but the provided cable is from the older style connector that the Uno used to come. And they just replaced, I'm guessing, the Uno out of the kit with an ESP32 without thinking to replace the cable. And included in the kit, we also have an expansion board that, again, has a USB-C and a USB-B mini connector. But I think they're just for powering the board, and I'm not sure if we can program that through it. Again, this cable doesn't fit in any of those, so it's just an addition that's not really usable. And this continues to many other things, including what excited me the most about this kit when I got it, because it has an OV2640 camera module in it. However, since this is an ESP32 room board, there is no camera connector on it, so we cannot directly plug it. And the camera module itself comes with a flat cable and the necessary connector, but again, we can't really do anything with it, and it's just an addition that we can't use with the kit, which is unfortunate. Now, what I do like a lot about the kit is the inclusion of the full-size breadboard, and this is a quality breadboard as well, including the jumper cable, so male to male and female to female, that we can use. And also this set of breadboard jumpers that are pre-wired with certain lengths, and that would save you quite a lot of time when you're working on some prototypes. We have a bag of components, including a lot of LEDs, potentiometers, optocoupler, motor drivers, and whatnot. There should be a tilt switch here as well. Yeah, that's the one here. And there's also an infrared receiver along with a suitable remote for ER projects. We have an RFID reader included with tag and card. We have 2 sets of relay boards that we can use to power our main appliances, and these are 5-volt relays. We have an LCD screen, we have a PR module, a small DC motor, some buzzers and piezo elements, a DHT11 I believe, or 22 temperature and humidity sensor. We have an ultrasonic module for distance measurement, a joystick, servo, and a display, as well as support resistors and also a battery for connections. Now the kit also comes with a USB key included that's 2 gigabytes that has an ebook on it that showcases some of the projects that you can do with the whole setup that you get. But that's also one thing that's not really well thought of, because it includes projects for sensors and components that you don't get with the kit, and you'll need to buy this separate from another kit or individual sensors if you want. However, the inclusion of the selected projects is still nice, and it can guide you through working with some of the components on the kit. Now, to make today's projects, we're going to be using the Keypad module that came with the kit and the ESP32 board. So we will interact with the keypad to send the required codes to the ESP that will then turn on and off certain lights, indicating that a certain system can be locked or unlocked or turned on or off. And the way that this works is that we have 8 connections here on this header. If you look closely, this is actually 2 connections of 4 wires each. And if I shine a light through the back of this, now if we take a look at the membrane with the backlight underneath, we're gonna see that some of the lines here are connected to the vertical columns of the pad, and some of the wires are connected to the rows here on the side. For example, these first 4 wires, 2 of them connect to the first 2 columns, and then the first 2 go up on the side and connect to the rows, and the other 2 here, they connect to this column and row. What this connection does, it allows us to address any combination that we press depending on which column and row combination is pressed. So for example, if we want 9, it's gonna be column 3 and row 3. If we want star, it's gonna be column 1 and row 4. So we're gonna know all of these connections to the pins as we have it on the ESP32. Now the module connection is fairly simple. We need to connect all of the 8 pins to 8 pins of the ESP32 that are input and outputs, and for that we're gonna use this stretch here from 19, 85, 17, 15, 4, 0, and 2, and we're just gonna plug this directly into the board. Now let's load the code, and this is the example code using the Keypad library that you can install directly from Arduino. We are defining the keypad that we have. So our keypad uses 4 columns and 4 rows, so we define that here, and then we define a matrix with all of the key combinations as we have it on the panel. So we have 1, 2, 3, A, then we have 4, 5, 6, B, and so on, finalizing with the star 0, sharp, or I'm not sure how that's called, and D. And we are defining the pins that we are using. So the first 4, 19, 18, 5, and 17 are the ones for the rows, and for the columns we have 16, 4, 0, and 2. Once we initialize this, inside the loop we are just getting any key press on repeat, and we are printing that in the serial monitor. So if we go in and, for example, press on the 5, we're gonna get 5 in the serial output. If we press 6, we're gonna get 6. If we press D and any of the other keypads, we are actually getting what we pressed based on the mapping that we did here in the column. Now let's expand that to add support that we can enter a certain key combination and the sharp symbol to trigger an LED on and off. Now to connect the LEDs, I'm gonna use the expander board that's included in the kit and the prototype board, but one of the other oversights at the moment that I'm facing is that we don't have female to male wires, so we have male to male and female to female. For the kit to be able to be connected to the breadboard, we need female to male cable, so I'm gonna use some of my own. And now here is the finalized example. I gave up on the extension board because for some reason I was getting a bad connection sometimes on the keypad, so I plugged it directly into the module and that seems to fix the issue. So in the current example, I've added an LED on pin 22 that has a suitable resistors, and now when I enter the codes that are programmed to the device, so 1, 2, 3, 4 for example, and press on the sharp symbol, the LED will turn on. Then when I enter the same or any other of the allowed codes, for example I have 5, 6, 7, 8, then the LED will turn off. In that case it didn't recognize the 7, so 7, 8, and that turns on. I also have 9999 as the code that will turn it on, and then using the same code that will turn it off. If we press some code and we made a mistake, we can press star to cancel and then press the code again to turn it on, or press another code to turn it off. In the code we have a very similar situation to before. Now we've added another definition for the LED pin, and this is 22 in my case, and the keypad remains the same. I have another variable for the allowed codes, and you can enter as many as you want here, and then a variable to control the LED state as well as the code that we've entered. In this setup we're initializing things as before, and I've added a debounce time to the keypad, so whenever we keep the finger pressed on the button it will not register multiple times. There are some messages for the start, and again we have the same thing where we're displaying the key pressed. If the key is the sharp symbol, then we're checking if the entered code is valid, and if it is, then we're just toggling the LED state, and if not, then we are just appending the code, and if it's a star, then we are just clearing the entire entered code. In the check code function, we're just taking the code that we have entered and looping and comparing it with any of the allowed codes. If we find a match, then we return true, otherwise we return false, and that will trigger the right condition here as we check it. And with that, I'm gonna end the video right here. You should now be able to use any keypad with an ESP32 to control anything that you want to connect with. As a final verdict on the EEmentor Kit, I think it provides a nice value with all the things that it includes for the given price, but keep in mind that it has some drawbacks and that you're gonna need some additional things to purchase if you want to fully use everything provided, like the camera here. And also you're gonna need a different cable to connect the ESP32, but other than that, the entire kit, I think it deserves its value. I'm gonna have links down below if you want to check it out. If you want to see me do more reviews of kits like this, then be sure to subscribe on the channel, and also let me know down in the video comments. I have a Patreon link that you can check out here and support my work if you want to. YouTube thinks that you're gonna like this video next, and I'm gonna see you all in the next one. Cheers!